Section 5.4 Differentiation and Integration of Exponential Functions. In this section, you will learn how to differentiate and integrate exponential functions of base e. Recall exponential function f of x equal e to the x. E is an irrational number approximately equal to 2.7, and the graph follows to the right. Y equal e to the x, as you can see, when x equal -1, y is equal to e to the -4th power, which is equal to 1 over e, which is approximately 0.37. So I have that point right there. When x equals 0, I get y equal e to the 0th power, which is 1. So I have a 0, 1. When x equal 1, y is e to the 1st power, which is e, which is approximately equal to 2.7. So I have a 1, e. So now, what would be domain for f of x equal e to the x? Well, I can plug any negative number for x, or 0, or any positive numbers. So domain is actually all real numbers. And what is the range? As you can see, even if I plug x equal negative number, it just gives me 1 over e to the positive exponent. And because both the numerator and denominators are positive number, it is still positive. E to the 0th power is 1. E to the positive power is a positive number. So you can see that e to the x function never can be 0 or negative. So therefore, range will be 0 to positive infinity. And what happens as x approaches to negative infinity, e to the x function? As x approaches to negative infinity, your y value is getting closer to 0. So the limit e to the x as x approaches to negative infinity is 0. So that means you have horizontal asymptote y equals 0. Now what happens if limit e to the x as x approaches to positive infinity? As you can see, as x approaches to positive infinity, your function value is getting bigger and bigger, and it is actually going to positive infinity. So you will only have one horizontal asymptote. Now, other attributes of the graph of fx equal e to the x. This e to the x, your base e, we said is approximately equal to 2.7, which is greater than 1. When you have an exponential function of a base greater than 1, we always get increasing function. So this is increasing function for all x in the domain negative infinity to positive infinity. And what would it be concavity for this graph? You can see that this is concave up since it's a cup shape. So this f of x equal e to the x is concave up for all x from negative infinity to positive infinity. This function is continuous for all real numbers, and it's differentiable for all real numbers. When you do the horizontal line test, every horizontal line meets with the graph at exactly 1 point, which tells you this is a one-to-one function, which implies inverse function of this function exists. In fact, for f of x equal e to the x, f inverse of x is natural log of x. So because they're inverses to each other, you know f composite f inverse of x equal x, and f inverse composite f of x is also x. Thus, ln of e to the x equal x, and e to the ln x equal x. Let's try a couple of algebra review problems. Give the domain and solve e to the 2x plus 1 equal 4. So what is the domain? Since this is exponential expression, domain is still all real numbers. So domain is negative infinity to positive infinity. And let's solve that. How do you solve it? Remember we just said at the end, because e to the x and natural log of x is inverses to each other. So you just saw that ln of e to the x is just x. So when you have exponential equation, you take ln function both sides. So you are going to take ln both sides. So you have ln e to the 2x plus 1 equal ln of 4. And because ln e to the x is just x, ln e to the 2x plus 1 is just 2x plus 1. That's equal to ln 4. To solve that, we need to subtract 1 from both sides. So you have a 2x equal ln 4, subtract 1. And I don't want to write minus 1 here, because then sometimes you think, oh, well, 4 minus 1 is 3. But that's not what it is, right? The input for ln is 4 only, and you are subtracting 1 from entire ln 4. So this is really bad writing. So if you have a natural log with the number added and subtracted, write that number in the front of ln instead of writing on the back. So we are going to rewrite this as -1 plus ln 4. That way, nobody's confused. And you are going to divide both sides by 2. So x is equal -1 plus ln 4 all over 2. And this will be your exact solution. However, it's hard to tell what this number is. Then you can use now calculator. If you would like to approximate to 3 decimal places, x will be approximately equal to 0.193. And it is approximation. All right, let's do another problem. Give the domain and solve ln x plus ln of quantity 2x minus 1 equals 0. So what is the domain of ln x and ln 2x minus 1? Since I have a 2 expression of natural log, I need to make sure both the input has to be positive. This has to be positive, and this has to be positive in order for this problem to make sense. So I need x to be greater than 0, and at the same time, I need the 2x minus 1 also greater than 0. And if I solve this, 2x has to be greater than 1, divide by 2 both sides, x has to be greater than 1/2. So I need the x that is greater than 0, and I need also x that is greater than 1/2 at the same time. It needs to satisfy both. So the inequality that satisfies both will be x greater than 1/2. So domain for this problem would be x greater than 1/2, which is 1/2 to infinity. All right, now let's go ahead and solve it. So when you have more than one log, then first thing you want to do is make a single log. That was the first step. From the properties of a logarithm, ln a plus ln b is ln of a times b. So I'm going to change this to single log, and it is ln x times 2x minus 1 equals 0. And that is ln 2x squared minus x equals 0. So now I need to change it to exponential equation to solve this. And base for ln is e. So now you have e to the 0th power equal 2x squared minus x. And e to the 0th power is 1. So you have a 1 equal 2x squared minus x. Since this is a quadratic equation, let's subtract 1 from both sides and set it equal to 0. So I have a 0 equal 2x squared minus x minus 1. And this guy factors. It factors as 0 equal 2x plus 1 times x minus 1. So either my x is -1/2 or x could be 1. But what is the domain for this problem? This problem will only make sense if x belongs to 1/2 to infinity, not included. So this cannot be the solution. So your solution will be only x equal 1. Okay, that was enough for algebra review. Let's do calculus now. Derivatives and integrals involving the exponential function. So what is the derivative of e to the x? Woohoo! Look at that. Derivative of e to the x is e to the x. This is my favorite derivatives because it's so easy. So derivative of e to the x is e to the x. However, if it's not e to the x, then it's e to the u. If exponent has a variable in it, right? Then you would need to use chain rule, which is no big deal. So derivative of e to the u respect to x is e to the u times u prime by chain rule. Now integrals of e to the x dx then is e to the x plus c. Since derivative of e to the x is e to the x, integral of e to the x is e to the x plus c. However, if it's not e to the x, then we could do u substitution method for integral, and you can substitute it as integral of e to the u du. Then it will be e to the u plus c, and you need to do the back substitution and replace by g of x, and your answer will be e to the g of x plus c. So what is the derivative of x squared times e to the 2x? Do you recall? What rule should we use here to take the derivative of product of x squared and e to the 2x? That's right. You gotta use product rule. So let's call x squared f and e to the 2x g. And product rule was we do f prime times g plus f times g prime. That's what the product rule was, right? So then when you take the derivative of x squared, I get 2x times g is just e to the 2x plus f. F is x squared g prime. Since it's not e to the x, it is e to the u. So you need to use chain rule here when you take the derivative of g. So derivative of e to the 2x is e to the u, use 2x, times u prime. And your u prime is 2, since derivative of 2x is 2. All right, can we write it in factored form? So what do they have in common? They both have a common factor 2x, I see. So let's take it out 2x. They also both have e to the 2x's power as a common factor. So let's take that out and open the parentheses. Then what I get from the first is 1, since everything is factored out. And from the second term, I will have an x only. So that will be my answer. Can you now integrate e to the negative x over 2 dx? And since this is not e to the x, we need to do the u sub. So what is on the exponent is what you're gonna call u. So let u be negative half x. Then du is negative 1/2 dx. Good. I only need number there, and that I have no problem creating it. Since I have to multiply negative 1/2 factor inside of integral, let's go ahead and multiply by negative 2 factor outside of integral. So then now I have negative 2 integral e to the negative x over 2. I'm going to create negative 1/2 factor dx. So if I do u sum now, this is equal to negative 2 integral e to the, what is negative half x? It is u. And negative 1/2 dx is your du. So then this is negative 2 times integral of e to the u is e to the u plus c. And what was your u? You do back substitution, you get negative 2 times e to the negative x over 2 plus c. So that is your final answer. Let's keep going. What's integral of e to the tangent x over cosine square x dx? Well, since it's not e to the x, it is e to the u. That means u is tangent x. Du should be then secant square x dx. I don't have a secant square. Yes, you do. You have a 1 over cosine square of x. And because secant x is 1 over cosine x, secant square x is 1 over cosine square x. So you do have du. So we're gonna let u equal tangent x. So then your du is secant square x dx. So you can rewrite this as integral of e to the tangent x, and 1 over cosine square x is secant square x dx. So then you do the u substitution, you get integral of e to the u du. Integral of e to the u du is e to the u plus c. Do the back substitution, u was equal to tangent x. My final answer is e to the tangent x plus c. How about integral of e to the 4 over x all over x squared dx? Again, since this is not e to the x, it must be to the u. So let's see. Let u be 4 over x. 4 over x is 4 times x to the negative 1 power. So then my du is negative 4 x to the negative second power dx, which is then equal to negative 4 times 1 over x squared dx. Do you have that? Almost. I have 1 over x squared dx. So all I need is negative 4 factor inside the integral. So we're going to create that and divide by negative 4 outside of integral. So now let's make this to negative 1/4 integral of e to the 4 over x squared. I need a negative 4 factor. So I'm going to have a negative 4 factor dx. So I'm ready to do the u sub. So then this is equal to negative 1/4 integral e to the u. Everything else that I have is all du. So then this is equal to negative 1/4 times integral of e to the u du is e to the u plus c. And negative 1/4 times my u was 4 over x plus c. So I'm done. So easy. I love it. You do too, right? Can you do definite integral this time? No problem, right? Since I don't have a e to the x, I must have a e to the u. So let u be equal to negative x squared over 2. Then my du is equal to derivative of negative x squared over 2 is negative 2x over 2 dx, where 2's get canceled. So my du is negative x dx. And since it's a definite integral, I also need to change the limit. Yes? So let's change the limit. What is the lower limit for x? When x equals 0, my u becomes negative 0 squared over 2, which is still 0. And when upper limit x equal radical 2, my u is negative radical 2 square over 2, which is then negative 2 over 2, which is negative 1. All right, now it's not quite ready to do the substitution because my du is negative x dx, and I only have x dx. So let's multiply negative 1 inside of integral and multiply negative 1 outside of integral as well. So I have negative integral of 0 to radical 2 negative x times e to the negative x squared over 2 dx. I'm ready now to do the substitution, which is equal to then negative integral. My lower limit was still 0. My upper limit when x was radical 2, my u became negative 1. E to the u. Negative x dx is my du. However, we don't integrate 0 to negative 1, right? So recall, integral b to a of fx dx is equal to negative integral a to b of f of x dx. So we are going to have another minus, but minus minus makes it plus now. And we're going to switch integral from now, negative 1 to 0 of e to the u du. And integral of e to the u is just e to the u. And because we already changed the limit, you can just use negative 1 to 0 there. And that will be e to the 0 minus e to the negative 1 power. And e to the 0's power is 1. And e to the negative 1 power is 1 over e. So this is your answer. And if you want a single fraction answer, this will be e over e minus 1 over e. So another way you could write the answer would be e minus 1 over e. Either way is fine. Find the relative extrema of f of x equal x squared times e to dx. So how do you find the relative extrema? You could do the first derivative test, right? So you find the derivative, f prime, and then you find the critical numbers, and then you draw the number line and locate the critical numbers. When f prime changes the sign before and after the critical number from positive to negative, that means your graph is increasing and then decreasing, so you have a relative max there. If f prime sign changes from negative to positive before and after the critical number, then because your function is decreasing and then increasing, you will have relative minimum at the critical number. So let's go ahead and find the relative extrema. To do that, first step is to find the f prime of x. Since my f of x equal x squared times e to the x, which is a product of two functions, we need to use product rule here. Since f is already used, let's call x squared g and e to the x h. Then the product rule would be f prime of x equal g prime times h plus g times h prime. And now g prime, derivative of x squared, is 2x, and h, we just copy e to the x, plus g, just copy x squared, h prime, derivative of e to the x is e to the x. To find the critical number, I'm going to factor this, and common factor is x and e to the x. Open. First term is 2. And from the second term, I'm only gonna get x there. And this is defined for all real numbers. So you are only gonna get the critical numbers by setting it equal to 0, because this is never undefined. And it is 0 when x equals 0 from the first factor. And then e to the x is never 0. And then 2 plus x factor is 0 if x was negative 2. So here is your two critical numbers. So now you're going to draw the number line. Locate the critical numbers. My critical numbers are negative 2 and 0. And I need to check the f prime sign in between critical numbers. First test point from the first interval, let's choose negative 3. From second, I'll choose negative 1. And third, I'll choose 1. And then, of course, you're going to plug it into factor the form of f prime of x to check the f prime sign. So x is negative 3, so that's a negative. E to the negative third power is 1 over e to the third power, which is positive. 2 plus negative 3 is negative. So when you multiply two negatives, you do get positive. When I try negative 1 for my test point, x, negative 1, which is negative. E to the negative 1 power, it is 1 over e, which is a positive number. And 2 plus negative 1 is positive. So whole product becomes negative. If you plug x equal 1, I get 1 equal positive. E to the first power is positive. 2 plus 1 is positive. So product is positive. So because your function is going to be then increasing here, and then decreasing here, and then increasing there. So then you will have relative max at this critical number, negative 2, and you will have relative min at this critical number, 0. So I'm going to answer now. So I do have a relative maximum, and it happens at x equal negative 2. And my maximum is f of negative 2. F of negative 2 is negative 2 squared times e to the negative second power, which is 4 times 1 over e squared, which is 4 over e squared. So that's your relative maximum. And your relative min happens when x equals 0. And f of 0 is equal to 0 squared times e to the 0's power, which is 0 times 1, which is 0. So you have a relative minimum 0, 0. So my answer is right here, relative max, negative 2, 4 over e squared, relative minimum 0, 0. Last problem. Find the equation of the tangent line at 1, 1 of 1 plus ln of xy equal e to the x minus y power. Whoa, this equation is not written explicitly. Do you see? Both left and right, I have a variable x and y, and I cannot solve it for y. So you're going to have to do implicit differentiation. Do you remember how to do it? I hope so. Okay, so the first step of implicit differentiation was you take the derivative of both sides with respect to x. So that will be d dx of 1 plus ln of xy is equal to d dx of e to the x minus y's power. So then you do regular derivatives for x. And when you take the derivative of a y variable, you're going to have to use a chain rule. So you're going to have to multiply by dy dx. So derivative of 1 is 0. Since this is not ln x, it's a ln u. Derivative of ln u was u prime over u, or 1 over u times u prime. So that's a 1 over u times u prime. And when I do u prime, I need to take the derivative of xy. And since xy is a product, I need to use product rule. So derivative of x is just 1 times y plus x times derivative of y is 1 times dy dx, which is equal to, this is not e to the x, so it is e to the u. So derivative of e to the u is e to the u times u prime. And that is e to the u times u prime. And my u prime, derivative of x is 1 minus derivative of y is 1 times dy dx. Alright, so then when you distribute this, y get canceled, and I will have 1 over x. Plus, when I distribute, I get x cancel. So I have 1 over y times dy dx is what I get, which is equal to e to the x minus y's power minus e to the x minus y's power dy dx. All right, what is the next step when you do the implicit differentiation? Do you remember? You want to collect the dy dx term in one side and send any other terms on the other hand side. So I'm going to leave 1 over y dy dx here. I'm going to move negative e to the x minus y's power dy dx to the left. So when it comes to the left, it becomes plus now, e to the x minus y power dy dx, which is equal to, I already had e to the x minus y's power on the right, and I'm going to move 1 over x to the right. So it's going to become negative 1 over x. And your next step of implicit differentiation was factor out dy dx. So I'm going to factor out dy dx, open, then I get 1 over y plus e to the x minus y's power equal e to the x minus y's power minus 1 over x. And that gives me one last step for dy dx. Remember, your goal is to find the dy dx at 1, 1. So to have dy dx isolated, of course, we're going to have to divide both sides by 1 over y plus e to the x minus y's power, 1 over y plus e to the x minus y's power. So then finally, you have dy dx is equal to e to the x minus y's power minus 1 over x over 1 over y plus e to the x minus y's power. Since I have 1 over x on the numerator and 1 over y in the denominator, which make this complex fraction, you are going to have to clean this up by multiplying top and bottom by LCD. The LCD will be x times y, which is xy. So multiply this by xy, multiply the denominator by xy as well. When you distribute, you get xy e to the x minus y minus x cancel, so you get y over y cancel, you get x plus xy e to the x minus y. This is your dy dx. So slope that I'm trying to find is evaluating dy dx at 1, 1. So plug x equal 1, y equal 1, I get 1 times e to the 1 minus 1 power minus 1 over 1 plus 1 times e to the 1 minus 1. So easy. 1 times 1 is 1, e to the 0 is 1. So I have a 1 minus 1 on the top, which is 0. In the bottom, I get 1 plus e to the 0 is 1, which is 0 over 2, but still 0. So slope is 0. What is the line whose slope is 0? That will be horizontal line. Horizontal line is equation of the form y equal number. But this line passed through 1, 1. So that y equal number, that number must be y coordinate of the point. Your equation of the tangent line is y equal 1. Here is equation of a tangent line. Or you could still use points law form of a line, right? You have a point 1, 1 and slope 0. So if you do points law form, I have y minus 1 equal 0 times x minus 1. And 0 times everything is 0. And you move negative 1 to the other hand side, and you have again y equal 1. All right, we're done with section 5.4. See you again in next section.